Hey everyone, welcome to this explainer. Today, we're popping the hood on modern artificial intelligence to see how it actually remembers and understands data. We're talking about a fundamental shift in how we search for information. So let's jump right in, because what we're looking at isn't just some minor software update. It's literally an entirely new way for computers to comprehend the world around us. I want you to imagine a world where you don't have to guess the exact right keyword to find the data you need. We have all been there, right? Frantically playing keyword roulette in some clunky company portal, just crossing your fingers and hoping you strike the exact phrasing the original author used. But what if the system actually understood your intent? What if it knew what you meant, no matter what words you typed?
To put this in perspective, think about these two statements. Customer did not receive the rebate payment, and dealer incentive settlement is still pending. Now, to us humans, it's pretty obvious these are talking about the exact same problem. But a traditional database, it completely misses the connection. It literally sees zero overlapping keywords. A vector database, on the other hand, instantly knows they mean the exact same thing. Crazy, right? Let's figure out how.
So, what exactly is a vector database? Basically, we need to look at how we're moving away from those rigid keyword matches and stepping into the realm of deep conceptual understanding. The real secret sauce here is something called a vector embedding. Now, when machine learning models, like the large language models we hear so much about, when they process unstructured data, like a text document, a picture, or an audio clip, they transform that raw data into a long list of numbers. And this list of numbers is what captures the deep features, the semantics, and the absolute core meaning of the data.
To us, a concept is just a word. But to an AI model, a concept is vast, multidimensional math. The model takes a phrase like dealer rebate payment issue and maps it across this massive array of numbers that is often like 768 dimensions long. Every single piece of text, image, or audio gets converted into these highly specific numerical coordinates.
Now, here's where it gets really cool. The crucial thing is what happens when you plot those coordinates. Conceptually similar items actually sit physically closer together in this high-dimensional mathematical space. It's essentially a giant map of meaning. So the words automobile and car might not share any letters, but their vector numbers place them right next to each other on this mathematical map. When you ask the database a question, it just looks for the data points that are physically closest to your question's coordinates. That's it.
This brings us to a massive paradigm shift. We're talking about the jump from exact search to semantic search. It's the difference between just finding matches and finding actual meaning.
Let's clear up a massive misconception right off the bat. Vector databases are absolutely not here to replace your traditional relational databases, like PostgreSQL or MySQL. If you need to find customer ID 10023, a standard SQL database is exactly what you want. It gives you precise retrieval based on structured exact matches. But vector databases? They handle the messy, unstructured stuff. They use specific algorithms, things like approximate nearest neighbor, to rapidly calculate spatial similarity instead of exact matches. So think of it as an entirely new data capability running right alongside your traditional systems, not replacing them.
Okay, let's talk about some real-world AI superpowers. Because at the end of the day, a vector database isn't just a place to store numbers. It's a tool that unlocks some incredibly practical applications for businesses.
This spatial distance technology unlocks some absolutely killer capabilities. First off, semantic search, finding answers without needing identical words, like we just talked about. It also powers RAG, which we'll dive into in a second. It fundamentally upgrades recommendation systems. You know when an e-commerce platform suggests something you actually want? That's them mapping your preferences to product vectors. It even enables media search. You can literally upload a photo of a shoe to find visual matches across millions of items. And crucially, it handles anomaly and fraud detection by instantly flagging data points that sit unusually far away from normal transaction clusters.
I mentioned RAG a second ago, which stands for Retrieval Augmented Generation. Honestly, this is arguably the most important concept in enterprise AI today. Instead of blindly trusting an AI model to just know everything or trying to stuff your entire company's history in the one single prompt, RAG flips the script. Here's how it works. You ask a question, that question gets converted into a vector, and the vector database instantly searches for the closest matching verified company documents. Then, those highly relevant documents are sent to the LLM so it can generate a precise, accurate answer. The vector database acts as an external, factual memory layer. This is literally how you stop AI from hallucinating and keep its answers grounded in your actual, real business data.
Now, let's shift gears and tackle the biggest intimidation factor out there. It is time to bust the hardware myth, because I promise you, you absolutely do not need a supercomputer to make this work.
You've probably heard this one before, right? Vector databases require huge GPU servers, which means they are extremely expensive. People see words like AI or machine learning, and they instantly panic, thinking their infrastructure costs are going to go through the roof. Well, here is the good news. That statement is completely incorrect. Here's the reality of the situation. Generating those embeddings, turning the text into numbers, yes, that definitely benefits from GPUs. But that happens before the database step. Searching the vectors, which is the database's actual job, only requires a standard CPU, some RAM, and a solid-state drive. Thanks to highly efficient vector indexes like HNSW, the retrieval process is incredibly lightweight. You absolutely do not need a massive GPU sitting next to your database just to run similarity searches. To put this into perspective, take a look at this tiny number, 3 kilobytes. That is the approximate storage size of a single raw vector with 768 dimensions. Just 3 KB. It is practically nothing.
And when you look at what that means at scale, the math is actually super surprising. 10,000 vectors? That's only about 30 megabytes. 100,000 vectors is roughly 300 megabytes. And what about a massive corporate knowledge base of 1 million vectors? It is roughly 3 gigabytes. Think about that. That easily fits right into the RAM of a standard laptop or a tiny virtual machine. You can start experimenting with this stuff using just 4 CPUs and 8 gigs of RAM. A corporate knowledge base simply does not require massive infrastructure right out of the gate.
And you might be wondering about software licensing costs. Try $0. Top-tier open-source tools like pgvector, Qdrant, Weaviate, and Milvus all have a $0 license cost to get started. You can literally learn this technology on a laptop using Docker completely for free and then scale up later when you actually need multi-region distributed infrastructure. So how do we actually implement this in the real world? Let's talk about enterprise AI architecture, and specifically how you bring AI to your data without totally overcomplicating your existing tech stack. For a lot of organizations, the best starting point isn't actually a brand new standalone database. It's an open source extension called pgvector running right inside PostgreSQL. Think about it. Your app already has users, tenants, permissions, and metadata all sitting happily in a relational database. It takes a ton of engineering overhead to build a separate vector database with a complex sync layer, managing 2 different security models, and maintaining 2 backup systems. It's a headache. Instead, you can just add a vector column directly to your existing PostgreSQL setup. Your relational data and your AI knowledge stay perfectly and securely together in one single location.
Let's look at a concrete enterprise example: digital discovery. Imagine you have 2,000 recorded meetings, 20,000 requirements, and hundreds of design docs scattered all over the place. You chunk these down into vectors. Suddenly, a meeting isn't just some transcript that gets forgotten in a folder. If you ask your system, show me every discussion where missing product characteristics affected accrual accounting for McKesson, the vector search completely bypasses exact keywords. It goes in and retrieves the precise contextual meaning from a random meeting held 6 months ago. It literally turns isolated scattered documents into a persistent, instantly searchable organizational memory.
Which leaves us with this final thought. We've seen that vector databases aren't just some toy for massive tech giants with limitless budgets. They're lightweight, they're highly accessible, and they are completely revolutionary in how they connect concepts rather than just matching keywords. So, the question is, how will you use vector databases to give your data a memory? Thank you so much for joining me on this explainer, and I really hope you're as excited to experiment with this technology as I am.